We talked about these kinds of names. And you sort of remember? I know 2 days is a lot of time when it comes to chemistry, but we had these two categories of metal, non-metal salts. One where the metal didn't have a change, didn't have a variable charge, and the other where it did. And if the metal had different possible charges, we had to tell it, we had to say what its charge was in parentheses. And if it only had one possible charge, then we leave the parentheses out. You sort of recall that, as far as you know? I know it'll take a little work, a little practice to get used to it. But that's what the week is for. So last couple bits of information about this. There's another set of ions that we haven't really talked about. And these are called the polyatomic ions. Hold on a second. This pen is screwed up. Let me reset it. It's kind of like a game. Okay. Maybe my writing will be a little straighter now. So polyatomic ions, as you might imagine from the word, are ions that have more than one atom in them. Up to this point, we've only looked at monoatomic ions. We've looked at chloride, sulfide, bromide, all that kind of stuff. But we haven't looked at the ions that have more than one atom in them. Does anybody know any polyatomic ions you may have heard of in your travels? Something? Yeah, the nitrate, for sure. Nitrate is one of them. Anybody else heard of ions that kind of sound like that? Yeah, pretty much. So things like nitrate, sulfate, acetate, those sorts of things. Have you heard of some of those words before? That's what we're referring to. So there's actually a list of just a handful of them that you're going to need to know for this class. And so we can use them in the names the same way we used these other kinds of ions to make names. So here are the polyatomic ions that you should know. Nitrate, which is NO3 minus. So let's take a look at that. That is one ion with a -1 charge overall, but the ion is made of a nitrogen and 3 oxygens. So it's a little different from what we've seen before. Unfortunately, there's no fun shortcut to figuring out the formulas and charges of polyatomic ions. You just have to know them. So you have to have this list, and you have to get it in your head with flashcards or whatever. There's a lot more, actually. If you go in and take chemistry, you'll have to learn some more, too. We're going to get a list of 7 that you need to know for this class. So I think you can do 7. I know some of you are in anatomy. You've memorized like 500 things a day, so it should be no problem. What? Yeah, but that stuff is not important. So you can just push that out of the way and just, you know. All right, so we got a few more here. Nitrate, carbonate. So here's what you remember with these ions. You remember the name, the formula, and the charge. You need to know the charge because when we balance them out in compounds, you need to know how many of this ion go with how many of this ion. So it's not enough to just know that carbonate is CO3. You have to know that it's CO3 with a -2 charge. Somebody should come up with like a good song or something, and you can teach us. Well, I'll remember. Okay, some more common ones. Sulfate, which is SO4 2-. Phosphate, which is PO4 3-. Bicarbonate, which is also known as hydrogen carbonate. That's HCO3-. Hydroxide, OH minus or HO minus. And then the last one is a positively charged one, ammonium, which is NH4 plus. So there's 7 polyatomic ions you should know. If you want to go learn some more, that's good too, but these are the ones you'll need for this class. And then when we make our compounds with the polyatomic ions, we don't do anything different except treat these as one thing together. And that's where sometimes the confusion comes in. Because they're made up of different ions, it seems like you should balance them in a compound differently, but actually it's all one thing together. So let me show you what that looks like. If we want to make, let's say, copper 2 phosphate, we have to look at both ions and then see how we can balance them out in a compound. So copper 2 is copper 2 plus. If you didn't know that copper was CO, you could look that up. And then phosphate, we know from this table and soon from your heads, is PO4 3 minus. So now how do we balance those 2 ions out in a compound? Remember how we did this on Monday? We need to make the charges balance. It needs to be 0 overall. So how can we make a compound that has an overall 0 charge from these 2 ions?
You will need 3 copper.
Right.
And 2 phosphate.
Right. So you need 3 copper and 2 phosphate. Right. Then you've got 6 plus and 6 minus overall. The way we write that compound is Cu PO4 2 with the PO4 in, whoops, no, that's not right. Cu3 PO4 2 with the PO4 in parentheses to show that it's the whole thing. We need the parentheses around it because otherwise it would look like PO42 because it would have it would have a 4 and a 2 right next to each other. So the parentheses tell us it's 2 of that whole phosphate ion with the copper. All right, so let's try it. You try this one. I'm going to give you 3 different ones, 2 that are words that you put in formulas, and then 1 that's a formula that you come up with a name using these polyatomic ions. I'll try to keep the list on the screen here. All right, so you see if you can write formulas for those first 2, and then a name for this third one, PbSO42. These names are looking good? Think so? All right, who's got sodium bicarbonate? We have a formula for that one? Yeah. Actually, when there's only one of them, we don't need the parentheses, but that's okay. You could have it. I mean, it doesn't hurt anything. But yeah, that's exactly right. What's the common name of sodium bicarbonate? Anybody know?
Baking soda.
Baking soda, yeah. What, potassium carbonate? The next one? Yeah. K2CO3 or CO3 2? Like that?
Yeah.
What do you think? Good? Not good? Pretty good? One issue with this one. Carbonate is 2 minus. So if we've got 2 of them, that's a 4 minus overall. And that's not going to balance with the 2 pluses. So this should really just be K2CO3. Let's check again how that works. See how that goes? The 2 pluses balance out the 2 minus. Yeah. All right, and then the final one. What is the name of PbSO42? Lead sulfate. Is that it? So we've got lead for the Pb, sulfate for the SO42. There's one other thing that we need to have here. Anybody know? Close. You're right. So we need a parentheses here because lead can have multiple possible charges. What is the charge on lead in this particular compound? It's not 2. Let's look at why that's not 2. It can really help to write out the ions. So according to this formula, we've got 2 SO4s and 1. Hello, computer. There we go. Oh. And 1 lead. So what does the charge on that lead have to be to balance out those 2 SO4 2 minuses? 4. Yeah. So that's got to be 4 plus. So that's lead. What? Lead 4 sulfate. Mouse is like moving around magically here. So the naming part doesn't change just because we have polyatomic ion. The technique is the same. The balancing the charges out is the same. All that's the same thing we did on Monday. But in order to do it properly, we have to make sure to know all of these names and charges. Anybody ever cook with baking soda, sodium bicarbonate? Sometimes. I learned a neat trick with it last night. You put it on squash, like butternut squash, and then it allows the browning reactions to take place at pressure cooker temperatures. So you can make like roasted tasting squash, but do it in the pressure cooker so it's fast. I don't know. You don't seem that impressed. It was really good. I was impressed. It was done in like 10 minutes. Usually squash takes a long time. My kids were not impressed either. They were like, gross. Where's our hot dogs? No, with the squash. All right, so the last category then of naming are the non-ionic compounds. Compounds that are not made of ions at all. And these are called molecular compounds or covalent compounds. And everybody likes these because they're easy to name. We will talk next week about what it means for a compound to be molecular or covalent. It has to do with the way that they share their electrons. But for our purposes of naming, all we need to be able to do is identify a molecular compound. And the way we're going to identify molecular compounds is that they're made of nonmetals. So all the stuff to the right of that stair step, if there's no metal involved in it, that's going to fit in this category. That make sense? Now, when you name these compounds, it's actually pretty easy, and the reason it's easy is because there are even more possibilities than with the ionic compounds. So we don't assume anything like charges. Here's some examples. Whoops. There's only a couple quick rules for naming these guys. Note that they're all made of nonmetals. There's no metals there. All the atoms in these compounds are to the right of that line. Now that doesn't mean metals can't form molecules, but not in what we'll see. So we can use that generalization. First rule is that the second atom kind of pretends it's an anion. And becomes the ide. Does anybody know what that first molecule's name is, just because you know it? Carbon dioxide. So that oxygen becomes ide, just like when it's an ion. That doesn't mean it's actually an ion. It's not in this compound, but we name it that way anyway. So the second atom becomes ide. And then the rest of the name, you just say, I'm going to move this a little bit out of the way so I can put the names down there. You just say however many atoms there are with these special prefixes that you've probably heard before. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, and hexa is 6. And it goes on, but we usually don't see more than 6 for the compounds that we'll be dealing with. So this one, as you may know, is called carbon dioxide. That di tells us that there are 2 oxygens. What about this third one right here, N2O? How would you name that one? Close. It's dinitrogen monoxide. Now, some of you might also recognize that as nitrous oxide, that's sort of its older common name. But the official way to name this using these rules would be dinitrogen monoxide. And what about N2O5? What? Say it again. N2O5 or NO2? Dinitrogen pentoxide, yeah. Usually as you notice here, when the second atom starts with a vowel like oxide, we drop the A off the prefix so that it's not dinitrogen pentaoxide, it's dinitrogen pentoxide, or monoxide, not monooxide. If you left that in there, it's not a big deal. I wouldn't mark it wrong, but it's not. We usually drop that one. The other thing that you notice that we drop is that we drop that mono prefix on the first atom if there's only one of them. So that's why carbon dioxide isn't monocarbon dioxide. It's just carbon dioxide. And so NO2 would be, anybody? Yeah, nitrogen dioxide. Now, writing the formulas for these is also much easier than the ion ones because you don't have to come up with the charges. You just write down whatever it says. So if we have phosphorus trichloride, what would you write? It's just phosphorus, so it's just the atom, not the ion. So it's just PCl3. And what about sulfur hexafluoride? You might need to look up the names, but yeah, I heard it somewhere. Go ahead. I don't know where this sound is coming from. The room is like bouncing it all around, so I'm trying to see. You have to like speak up. Yes. Okay, thanks. That one I heard. SF6. There's like a fan and there's these kind of like low voices and I don't know. It's playing tricks on me. So you can see how that names go directly to the compounds. The tricky thing with naming these types of compounds is that these rules are so much easier that everybody wants to use this for all the other compounds, and that's not right. So everybody wants to use these rules for the ionic compounds and call things like this lead dioxide, which is not really the right name. So the trickiest part of naming is what about when things aren't in the categories? How do you determine the name and how do you write the formula? So the last thing we're going to do before we go in lab is I'm going to give you a couple names and a couple formulas, and I want you to write the names from the formulas and the formulas from the names, but I'm not going to tell you what category they fit in. So you have to come up with what type of naming rules to use based on the 3 categories that we've talked about. A periodic table with the names might be helpful too if you have one handy. All right, so you got 2 formulas and 2 names. See if you can write the names from the formulas and the formulas from the names. Once you've got these written down, I'm going to switch this so I can pull up the lab. All right, what do you got for this first one? PDNO32. What's PD? Did you find that? Palladium, yeah, or palladium. So what do we call this one? Just lots of confusion. Well, we've got palladium and we've got nitrate. So each nitrate is -1. So what does the palladium have to be to balance that out? 2. So this is going to be palladium 2 nitrate. Because palladium is in that middle of the periodic table, which tells us that it can have more than one possible charge. So we specified the charge with the parentheses. What about K2O? You get that one? Yeah, this one's just potassium oxide. No number in parentheses because potassium can only have one charge, which is +1 from being in the first group. Yeah.
Just a question on like those metals that could have different charges.
Mm-hmm.
So that's anything from the transition elements,
Pretty much.
and then is it also row 3A and 4A?
Yeah.
Or is it just 4?
It's pretty much anything anything to the left of the staircase besides 1 and 2. There are a couple exceptions, which are zinc and aluminum. But for our purposes, it's anything that's not in groups 1 or 2, but that's still under the metal staircase.
Okay.
All right, so what do you have for a formula for diphosphorus pentoxide? Maybe that one?
P2O5.
Yeah. P2O5. 2 phosphorus, 5 oxygen. That's easy. And then finally, nickel 2 carbonate. Yeah, that one too.
ICO3.
Yeah. Carbonate is -2. Nickel 2 is +2 because we're told that it's +2 because it's nickel 2. So you got 2 + 2 - those balance out. All right. So this is going to take a little practice. Take a look at the problems in the book. You can always look up stuff online, naming, ionic compounds, that kind of stuff. There's a lot of practice out there. Let me know if you're having trouble. Mostly it just takes doing it over and over again and getting those polyatomic ions in your head. So let's talk about labs. We can do that.